Hello everybody, I'm back, ready to make another video. I've sent you an email. Today we're starting new stuff. So far it's just been review. I've been moving quicker. So I'm gonna try and teach in depth, but you need to understand that as a teacher, I guide my teaching throughout a lesson based off of your verbal and nonverbal communication to me. And so if I feel like people aren't getting it, I can always slow down or speed up if they're getting bored. So I don't have that now. So I'm going to do the best I can. Probably going to make mistakes, do things that aren't that great, but just bear with me. Again, you can always let me know in the comments or with email if something didn't make sense, if you want me to go through something specific. I could even record myself doing specific problems if there's some that you're stuck on. So this is pretty easy for me to do. I'm starting to get the hang of it for sure. And I don't know, my goal is just to help you keep moving. All right. So with that being said, you've got today's worksheets. Today we are learning about Pythagorean Theorem. So let's do it. Pythagorean Theorem. Some of you have probably heard of it before. Maybe for some of you, it's a brand new thing. But that's just really the name of a formula, an equation. And this is what it is. A squared plus B squared equals C squared. That is Pythagorean theorem. Okay? And so really what you need to know how to do is how to recognize when to use Pythagorean theorem. And secondly, how you actually use Pythagorean theorem once you know that's what you're supposed to use it for. So let's start with, so I'll write that over here. So you need to know when to use it, and you need to know how to use it. If you've been in my class, then the how to use it part is going to be super easy for you. You've done some algebra with me that was way beyond what you're going to need to know how to do here. Okay. Now you are going to need a calculator. So when we use Pythagorean theorem, you're going to need the square root function on a calculator. So you know where that is on the calculators we use in school. You may not know how to find that, like for instance, if you're using the calculator on your phone. I know on iPhones and probably most other phones, if you pull up your calculator and then you turn it to the side, let me show you on my phone, then it's going to give you more of a screen. Okay, so here's my normal calculator screen. If I turn it to the side, of course, it's not going to do it. Maybe that's because it's locked. Let me unlock it and pull up my actual calculator. Okay. Oh, I'm glad that happened because the same thing may happen to you. I hadn't unlocked my phone. All right, so when you're looking at the iPhone, you can see it looks like it's third row down, second button over right here. It's got a 2, really hard to tell, 2, and then the square root button and an X. All right, so if you need more help on that, let me know and I'll try and help you out. You can also pull up calculators on the computer that will have it. So back to the lesson. So when do you use Pythagorean theorem? We're talking about geometry, right? So you use Pythagorean theorem when you need to know the missing side of a right triangle. All right? So I'll just draw a basic right triangle. If it's a triangle and it has a right angle in it, then it's a right triangle, okay? And Pythagorean theorem is the method, the formula that we're going to use to find the missing side of a right triangle. So let me just go ahead and label these sides. Okay, A, B, and C. Actually, A and B are interchangeable. I could have written this side as an A and this side as a B. They're interchangeable. The one that's not interchangeable is C. Okay, and so when you are looking at a right triangle, you want to find that right angle. I see the right angle, and what I know is that the right angle is always formed by the two legs. Okay, we call these legs. A and B are the legs of the right triangle. That's what the right angle stands on, the legs. All right, so that leaves the third side. Oh, drop my marker. That leaves the third side as C. It's always directly across from the right angle. It has the name of hypotenuse. Okay, hypotenuse is always the C. Now, what we know about right triangles is that the longest side of every right triangle is the hypotenuse across from the 90-degree angle. It's a property of triangles. Across from the largest angle is the largest side. A 90-degree angle would be the largest angle of a triangle. Across from it is the hypotenuse. Okay, so your two legs are going to be shorter individually than the hypotenuse. But another property is that your two legs together will always be more than the hypotenuse. Okay, so if I know these two numbers and add them together, they have to be more than the C. But the C is more than the A and the B individually, if that makes sense. Okay, and we'll come back to that in a little bit. So notice in Pythagorean theorem, our A, our B, and our C. As far as the theorem is concerned, the only thing that changes are these three letters. Everything else is see it. So, sorry, let me get rid of this. All right. So let's take a look at some numbers. All right, I'm going to pull these letters out. And put some numbers in. All right, so here's a right triangle. I can see that this side has a length of 3, which actually, let me switch that around. That's a little bit longer. I don't want to confuse anybody, but this looks longer to me than that. So let's call this side 4. Let's call this side 3. And what we want to know is the distance of this third side. We don't know it, but that's the perfect opportunity to use Pythagorean theorem. It's a right triangle, and we know 2 of the sides. So we can use Pythagorean theorem to find the third side. So let's go to the theorem itself, okay? We're going to replace the letters with the numbers. So we have these 2 sides, which make the right angle. So we have the legs, which are A and B in the problem. Okay, so replace your A and your B with our numbers. So A is 4. So 4 to the second power, 4 squared plus 3 squared equals, now this I don't know. I don't know what this is. So I'm going to keep it as C squared. Hard part's done. Hard part is recognizing you need to use Pythagorean theorem and making sure you got your numbers in the right spot. Now we just do the algebra. Okay, this is the easy part if you've been in my class. So start by squaring these numbers. 4 squared, that means 4 times 4. 4 times 4 is 16. Bring down your addition sign. 3 squared, 3 times 3, 9, equals c squared. Follow me so far? Take our numbers, put them together. 16 plus 9 is 25. So 25 is equal to c squared. So at this point, especially when you're first learning this skill, you might think you're done, okay? You've kind of isolated your variable and you've got an answer here. And so you might consider calling that side 25. But if you think back to what I told you a minute ago, and really it doesn't make sense for that to be 25. But if you think back what I said, this is 3 and this is 4. Together, if I added 3 and 4, that's 7. This cannot be 7 or more. It must be less than 7. But it must be more than 3 and also more than 4. Okay, that's just what we know about the hypotenuse, the C side. So 25 doesn't make sense, but if you're taking a test, that's probably going to be the first answer choice that they have on there, because you might be excited you got it right, or you think you got it right because the answer's on there. But there's one last step, because 25 is actually equal to c squared. We're trying to find c, not c squared. And so we need to think about that. What number squared is 25? What number squared is 25? What number times itself equals 25? If you think about that, that's 5. 5 times 5 is 25. Okay? I'm going to rewrite this here. So this is where we're at. And we've just reasoned out that the answer is 5. But here's how we do it mathematically. And this is actually how we're going to end every Pythagorean theorem problem, regardless of which side you're looking for. Your last step is always square root. Okay? Why are we square rooting? Because we have c squared here, and we want to bring this down from c squared to c. All right? So if you think about what square root means, it's what times itself equals something. So what times itself equals c squared? Well, that would be c. c times c is c squared. So the square root of c squared is c. What I do to one side, I do to the other. Square root of 25 is 5, okay? And if we go back to our triangle, we can see 5 is more than 3 and 4, so it meets that rule. It is less, though, than these two together. If you think about this in common terms, like let's say these are blocks, like you're taking a walk to your buddy's house, okay? If we started here, and we walked 3 blocks west, and then we turned and walked 4 blocks north, okay? That would be a total of 7 blocks that we walked. But one thing you've probably heard is the shortest distance between two things is a straight line, okay? So if I start here and end here, really the fastest way home would be to cut through everybody's yards and go straight home instead of following the roads. That would be the shortest distance from one spot straight to the other, not down and over. Okay? So if down and over is 7, straight there has to be more than 7. Hopefully that helps make that make a little bit more sense. Okay? So that was a little bit about how to use Pythagorean theorem. Remember, you use it when you're missing a side of a right triangle. And we're going to do several example problems. We'll do some word problems just to try and, show you what kind of problems they look like. Okay? So that was an example where we have the 2 legs. Put them in for A and B, and we solve for C.